The universe is not hostile toward you. It's worse than that. It's completely indifferent. And indifference, at cosmic scale, is the most terrifying thing that exists. These are every way the universe could kill you. And there is nowhere to run. Right now, somewhere in the observable universe, a star is dying. Not quietly. Not slowly. In a fraction of a second, its core is collapsing. Its outer layers are detonating, and it is releasing more energy in that single moment than our sun will produce across its entire 10 billion year lifetime. And from that explosion, two beams of pure energy are firing outward into space at the speed of light. A gamma ray burst, the most energetic explosive events in the observable universe since the Big Bang itself. A focused beam of gamma radiation so intense that if one were aimed at Earth from anywhere within our galaxy, from up to 8,000 light-years away, it would strip our ozone layer in seconds, completely, irreversibly, gone. And then the sun's ultraviolet radiation would do the rest. Without the ozone layer, UV radiation reaches the surface unfiltered. Photosynthesis collapses, the food chain inverts, mass extinction unfolds not in millennia, but in years. No explosion, no impact, no fire, just light. Arriving at the speed of light, giving zero warning, and quietly dismantling the biological infrastructure of an entire planet before anyone understood what was happening. Here is what makes this worse. A gamma ray burst aimed at Earth would be invisible until it arrived. Gamma rays travel at the speed of light. Any early warning system would require detecting the burst before the radiation, which is physically impossible. The first sign that a gamma ray burst had fired in our direction would be the ozone layer beginning to disappear. Some scientists have proposed that the Ordovician mass extinction, 450 million years ago, which wiped out approximately 85% of all species on Earth, may have been triggered by a gamma ray burst. We don't know for certain. We may never know. But we know this. We have detected over 10,000 gamma ray bursts since we developed the instruments to find them. They are common. They are powerful. And they fire in random directions across the universe with no regard for what happens to be in the way. You would never see it coming. There are an estimated 100 million stellar black holes in the Milky Way. We have located a small fraction of them. The rest are invisible, cold, silent, moving through the galaxy on trajectories we cannot track, carrying no light, emitting no radiation, announcing their presence only through the gravity they exert on whatever is unfortunate enough to be nearby. Some of them are moving fast. When a massive star dies in a supernova, the explosion is rarely perfectly symmetrical. The asymmetrical blast can give the resulting black hole a powerful natal kick, sending it careening through the galaxy at hundreds of kilometers per second. These are rogue black holes, ejected from their birth locations, unbound from any stellar companion, moving through interstellar space on unpredictable trajectories. A rogue stellar black hole approaching our solar system would be undetectable until it was extremely close. No light, no radiation, just a subtle gravitational influence that would only become apparent when it was already within the outer reaches of our solar system, by which point the gravitational disruption would already be underway. What would a rogue black hole do to our solar system? It depends on the trajectory. A distant pass, not close enough to directly affect the inner planets, could still gravitationally destabilize the Oort cloud, sending thousands of comets into the inner solar system over thousands of years. A closer pass would begin disrupting planetary orbits, shifting Earth's trajectory, altering our distance from the Sun, potentially ending the stable climate that complex life requires. A direct approach toward the inner solar system would be extinction level at minimum, tidal forces stretching and compressing the Earth. Orbital mechanics thrown into chaos. The gravitational architecture of the solar system, built and stabilized over 4.5 billion years, dismantled in millennia. And then, after passing through, the black hole would continue on its way. Invisible, indifferent, moving through the galaxy as if nothing had happened. We are not currently tracking any rogue black holes on collision courses with our solar system. The key word is currently. You've already heard about gamma ray bursts from dying stars, but the explosion itself, the supernova, is its own category of threat. And unlike a gamma ray burst, a supernova doesn't need to aim at you. It just needs to be close enough. Within approximately 25 to 50 light-years of Earth, a supernova would be catastrophic. The gamma radiation, X-rays, and energetic particles from the explosion would again strip the ozone layer. But the threat doesn't end there. The expanding shockwave of a nearby supernova would compress the heliosphere, the protective bubble of solar wind that shields our solar system from interstellar radiation, potentially exposing Earth to elevated cosmic ray bombardment for thousands of years. The good news is that no star currently within the danger zone is massive enough to go supernova. The concerning news is that the danger zone has been breached before. Evidence preserved in deep-sea sediments and lunar rocks suggests that Earth has experienced elevated radioactive isotope deposition, specifically iron-60, a product of supernova nucleosynthesis, at several points in geological history. The most recent significant event appears to have occurred approximately 2 to 3 million years ago, when a supernova detonated within a few hundred light-years of Earth. This event roughly coincides with the onset of the Pleistocene, a period of significant climate cooling and faunal turnover that ultimately reshaped the evolutionary landscape of Earth's large mammals. We didn't cause this. A dead star did. And Betelgeuse, the red supergiant in Orion, visible tonight in the winter sky, is in its final evolutionary phase. It will explode. Not tonight, probably not in our lifetimes, but on an astronomical timescale that is essentially now. At 700 light-years away, it is safely outside the danger zone. It will be the greatest light show in human history. But the universe doesn't always position its detonation so conveniently. If a supernova is a nuclear bomb, a magnetar is something the laws of physics invented specifically to be unreasonable. A magnetar is a neutron star with a magnetic field, so powerful it represents the strongest known magnetic field in the universe, approximately 10 to the power of 15 Gauss. To put that in perspective, Earth's magnetic field is approximately half a Gauss. The magnets in an MRI machine are roughly 30,000 Gauss. A magnetar's magnetic field is a quadrillion times stronger than Earth's. At that field strength, physics begins doing things that have no analog in everyday experience. The magnetic field of a magnetar is strong enough to distort the shape of individual atoms, stretching them into cylinders along field lines. It is strong enough to interfere with quantum mechanical processes in the vacuum of space itself, a phenomenon called vacuum birefringence. It is strong enough that if a magnetar were positioned halfway between Earth and the Moon, roughly 120,000 miles away, its magnetic field would be sufficient to erase every credit card on Earth. That is the minor concern. The major concern is magnetar flares. Periodically, magnetars release sudden catastrophic bursts of energy, starquakes driven by the stress of their extreme magnetic fields, cracking the neutron star crust. These flares release in fractions of a second more energy than our Sun produces in 100,000 years. On December 27, 2004, a magnetar flare from SGR 1806-20 reached Earth. The magnetar was 50,000 light-years away, on the other side of the galaxy. The flare was so powerful that it ionized the upper atmosphere and measurably disrupted Earth's ionosphere. Satellites detected it. Ground-based instruments detected it. From 50,000 light-years away, a fraction of a second burst of energy disrupted our planet's atmosphere. If SGR 1806-20 were 10 light-years away instead of 50,000, that same flare would have been an extinction event. There is a magnetar 10 light-years away from Earth. Just kidding. There isn't. But there are magnetars in our galaxy, and we don't know all of their locations, and their flares arrive at the speed of light. Sleep well. Not everything dangerous in the universe announces itself with a blaze of radiation or a gravitational anomaly. Some threats are quiet, dark, cold. Rogue planets, also called free-floating planets or interstellar planets, are planetary mass objects that have been ejected from their home solar systems and now travel through interstellar space, unbound to any star. No sun to orbit, no light to reflect, just a dark, cold, massive body moving silently through the galaxy. How many are there? The estimates are staggering. Recent gravitational microlensing surveys suggest that rogue planets may outnumber stars in the Milky Way. For every star in our galaxy, there may be several free-floating planetary mass objects drifting through the interstellar void. Hundreds of billions of dark invisible, massive objects moving through the galaxy on trajectories that nobody is tracking because we can barely detect them at all. A rogue planet on a trajectory through our solar system would be gravitationally significant. Depending on its mass, anywhere from a small rocky world to a super Jupiter, a close pass could disrupt the orbits of the outer planets, destabilize the Oort cloud, or in an extreme case directly threaten the inner solar system. The probability of a direct hit on Earth is vanishingly small, but a near miss, gravitationally speaking, could be sufficient. A rogue Jupiter-mass planet passing through the outer solar system could scatter asteroids and comets inward like a cue ball striking a rack, producing an extended bombardment of the inner solar system lasting thousands of years. The last major bombardment period in our solar system's history, the Late Heavy Bombardment, approximately 4 billion years ago, may have been triggered by exactly this kind of gravitational disruption. We are not currently detecting any rogue planets approaching our solar system. We are also not currently capable of detecting rogue planets approaching our solar system until they are very close. These are two different statements that are easy to confuse. Everything we've discussed so far has been external. Threats arriving from the wider universe, things happening elsewhere that might reach us. This one is closer. In approximately 5 billion years, the Sun will exhaust its hydrogen fuel supply. The core will contract. The outer layers will expand. The Sun will swell into a red giant, growing large enough to potentially engulf the orbit of Earth. Whether Earth is physically swallowed or not depends on competing factors. The Sun's expansion radius versus the outward migration of Earth's orbit as the Sun loses mass. Current models suggest Earth may just barely escape engulfment. May. But engulfment is not the relevant threat. The relevant threat comes much earlier, as the Sun brightens on the main sequence. A process already underway, the habitable zone migrates outward. In approximately 1 billion years, the Sun will be approximately 10% more luminous than it is today. That increase in luminosity will be sufficient to initiate a runaway greenhouse effect on Earth. The oceans beginning to evaporate, water vapor accumulating in the atmosphere, trapping more heat, accelerating the evaporation, until the oceans are gone entirely. Not in 5 billion years, in 1 billion years. And 1 billion years sounds like a long time until you consider that complex multicellular life on Earth has only existed for approximately 600 million years. We are closer to the end of Earth's habitability window than we are to the beginning of complex life. The Sun that made us possible is already, slowly, making us impossible. It's not malicious. It's not targeted. It's just a star doing what stars do, getting gradually brighter as it ages, indifferent to the thin film of biology clinging to the third rock out. The Sun gave us everything, and it will take it all back. Everything so far has been violent, energetic, detectable. Things that arrive with warning signs: radiation, gravitational disturbances, visible phenomena. This one has no warning sign, because the warning sign travels at the speed of light, and so does the threat. Vacuum decay is the most terrifying concept in theoretical physics, and it begins with a question about the nature of reality itself. The universe exists in a particular quantum state, the vacuum state, the lowest energy configuration of all the quantum fields that make up reality. But physicists have calculated that this vacuum state may not be the true lowest energy state possible. It may be a metastable state, a local minimum rather than a global minimum, like a ball sitting in a shallow valley on the side of a hill, appearing stable, but with a lower valley somewhere further down the slope. If this is correct, then somewhere in the universe, at any moment, a quantum fluctuation could nucleate a bubble of true vacuum, a region where the quantum fields spontaneously transition to their actual lowest energy state. That bubble would expand at the speed of light. Inside the bubble, the physical constants of the universe, the strengths of fundamental forces, the masses of fundamental particles, the rules that govern chemistry and nuclear physics, and everything that makes matter behave the way it does, would be different. Not just slightly different, fundamentally, completely, incompatibly different. Atoms as we know them would cease to be stable. Chemistry as we know it would cease to exist. Matter as we know it would be restructured or destroyed. The bubble wall would arrive at the speed of light. There would be no warning, no flash of light preceding it, no gravitational wave, no detectable precursor of any kind. One moment everything would be normal. The next moment, in less than a single Planck time, you, Earth, the solar system, and everything within the bubble's radius would be restructured according to physical laws incompatible with your existence. You would not experience it. There is no experience of it. The transition is instantaneous and absolute. Current measurements of the Higgs boson mass suggest that the universe's vacuum state is either stable or metastable, right on the boundary between safe and terminally unstable. We cannot currently determine which side of that boundary we are on. The universe may be fine, or it may be a bubble away from ending, and we would never know which until it was already over. Every threat so far has been external, sudden, violent, something arriving and doing damage. The heat death of the universe is different. It doesn't arrive, it accumulates. It is not an event, it is a destination. The end state toward which the entire universe is slowly, inevitably, irreversibly moving. The second law of thermodynamics states that entropy, disorder, in a closed system always increases over time. Energy spontaneously flows from concentrated, ordered, useful states to dispersed, disordered, useless states. Every star that burns, every black hole that radiates, Hawking radiation, every physical process that occurs, increases the total entropy of the universe. And entropy cannot be reversed. In the far future, on timescales so vast they make the current age of the universe look like a rounding error, this process reaches its conclusion. Stars exhaust their fuel and die. Black holes evaporate via Hawking radiation over incomprehensible timescales. The last protons decay. the universe reaches a state of maximum entropy, thermal equilibrium, where no energy gradients exist, no work can be done, no structure can form, no information can be processed. Temperature everywhere in the universe approaches absolute zero asymptotically. Nothing happens, not because nothing is allowed to happen, but because there is no longer any energy differential to drive any process. The universe persists, technically, but in a state so devoid of structure or activity that the distinction between existence and non-existence becomes philosophically unclear. This is the heat death. Not a bang, not a collapse. Just an endless, silent, cold dispersal of everything into nothing useful. It is the most certain fate in physics. Not probable, certain. The second law of thermodynamics is not a guideline. It is not a tendency. It is absolute. The universe began in an extraordinarily low entropy state, the Big Bang, and has been spending that initial order ever since. Every moment of complexity, every star, every life, every thought, is a temporary eddy in the irreversible flow toward maximum disorder. We are not threatened by the heat death. We will be long gone before even the first stars die. But everything we are, everything we have built, everything we love, is made of borrowed order, and the universe always collects its debts. The heat death assumes the universe continues expanding at its current rate. The expansion driven by dark energy, the fabric of space stretching gradually and uniformly, galaxies drifting apart over billions of years. But dark energy is not well understood. We know it exists. We know it is causing the universe's expansion to accelerate. We do not know if its strength is constant. If dark energy increases in strength over time, a scenario described by certain models as phantom dark energy, the consequences are not a gradual heat death. They are something far more abrupt. The Big Rip. In a Big Rip scenario, dark energy grows progressively stronger over time, accelerating the expansion of space more and more aggressively. At first, the effect is only noticeable at the largest scales. Galaxy clusters begin to be pulled apart, then individual galaxies, then solar systems, then planetary systems, then planets themselves. In the final moments before the Big Rip, and current models place this at roughly 200 billion years from now, if it happens at all, the expansion of space becomes so rapid that it overcomes every other force in the universe. Gravity, electromagnetism, the strong nuclear force. In the final billion years, the Milky Way is torn apart. In the final million years, solar systems are disrupted. In the final months, planets are ripped from their surfaces outward. In the final minutes, stars explode as the expansion overcomes the pressure balance of stellar interiors. In the final seconds, atoms are torn apart. Electrons rip from nuclei as the expanding space between them overcomes the electromagnetic force, binding them together. In the final fractions of a second, atomic nuclei themselves are torn apart, the strong nuclear force overwhelmed by the expansion of space at subatomic scales. And then space-time itself tears, the fabric of the universe reaching a singularity of infinite expansion rate. Not a quiet heat death, not a gradual dimming, a violent, escalating, all-encompassing destruction that ends with the fundamental fabric of reality being torn apart at the quantum level. Current observations are consistent with a cosmological constant, dark energy that doesn't change over time, which would mean no Big Rip. But the error bars on our measurements of dark energy are large enough that phantom dark energy cannot be ruled out. We don't know which ending the universe has chosen, and we won't know until it's too late to do anything about it. 9 ways, 9 completely different expressions of the same fundamental truth. The universe is not safe. A gamma-ray burst that arrives at the speed of light with zero warning. A rogue black hole moving invisibly through the galaxy. A nearby star detonating and dismantling our atmosphere. A magnetar flare that crosses the galaxy and disrupts Earth's ionosphere from 50,000 light-years away. A dark, silent rogue planet moving through our solar system on a trajectory nobody is tracking. The sun that made us slowly making us impossible. A bubble of true vacuum expanding at the speed of light and restructuring the laws of physics themselves. The universe dispersing every ordered thing into thermal equilibrium over incomprehensible timescales. And dark energy potentially growing strong enough to tear apart atoms, nuclei, and space-time itself. None of these care about you. None of these are aimed at you. That is the point. The universe does not have enemies. It does not have targets. It simply has physics, and physics, applied at cosmic scale, across cosmic time, produces outcomes that no biology, no technology, no civilization has ever survived. You are alive in a universe that is actively, continuously, indifferently trying to end you. And somehow against all of it, here you are. Subscribe while you still can.